My name is Lynette Roberts, and in this video I want to tell you about some of the research Jenny Richmond and I conducted looking at learning and memory processes in preschoolers with Down syndrome. You might ask, why were we interested in understanding these processes in people with Down syndrome? Well, we know that adults with Down syndrome show a specific profile of learning and memory deficits on tasks that depend on the hippocampus and the prefrontal cortex. These deficits present over and above the generalized cognitive delay that characterizes this syndrome. Given that these impairments are caused by a genetic abnormality that is present from birth, there is also an assumption that the cognitive deficits are also static, unchangeable, and present from day one. However, these cognitive functions have been primarily investigated in adolescents and adults with Down syndrome, and it's largely unclear how these processes develop in young children. Our study aimed to test whether the learning and memory deficits that characterize Down syndrome are present from birth or whether they emerge gradually with development. Down syndrome is caused by the presence of an additional chromosome 21. Understanding the specific neurocognitive consequences of having an additional chromosome has important implications for designing effective early intervention programs. It's particularly important to know not only if preschoolers with Down syndrome struggle with learning and memory generally, but also whether they have difficulty learning information initially and/or remembering it over time. To test this, we administered a battery of tasks that depend on the hippocampus and the prefrontal cortex, including relational learning, deferred imitation, place learning, and executive function tasks. We compared the performance of preschoolers with Down syndrome to control children, matched on both receptive language and non-verbal mental age. Although preschoolers with Down syndrome showed a generalized cognitive delay, evidenced by a significantly lower mental age relative to chronological age, to our surprise, they did not show the additional disability-specific hippocampal and prefrontal deficits that are seen in adolescents and adults with Down syndrome. Essentially, when matched on mental age, preschoolers with Down syndrome performed equivalently to controls. This surprising result challenges the assumption that because the cognitive impairments seen in people with Down syndrome are caused by a genetic abnormality, they must be present from birth. In the case of learning and memory impairments at least, it seems that the phenotypic implications of having an additional chromosome 21 may emerge over development. Disability-specific learning and memory deficits in individuals with Down syndrome may not be as pronounced in early development as they are later in development. Our results reinforce the idea that early childhood may be a critical time frame for early intervention. The preschoolers with Down syndrome in our study exhibited a generalized cognitive delay relative to controls. Their mental age on average was 23 months, while their chronological age was 52 months. However, the preschoolers with Down syndrome in our study did not show additional disability-specific learning and memory deficits. It is likely, given what we know about learning and memory in adolescents and adults with Down syndrome, that at some point during middle childhood or adolescence, children will begin to exhibit these extra impairments. Since we know much more about the nature of these hippocampal and prefrontal deficits in adulthood, we can begin to specifically target them in childhood as a form of preemptive intervention. Current early intervention programs aimed at promoting subject-specific skills such as reading depend on these basic learning and memory processes. To capitalize on this fact, intervention programs should also focus on improving general learning and memory processes, such as encoding strategies. Training general learning and memory strategies alongside subject-specific skills may result in learning improvements that generalize across an array of academic skills in children with Down syndrome. These modifications to intervention programs may assist to enhance the developmental outcome of children with Down syndrome. Thank you, and we hope you enjoy our paper.